Good morning, everyone, and welcome to the May edition of the Center for Tech Grove and NTSA Connect series of seminars as we get into deeper dives around EdSec 2020 presentations. And today we have a great group of presenters that will be talking about how a medical application can potentially address a growing crisis in military training. It's based on a paper that was submitted by Dr. Court Horton, Dr. J.J. Walcott, Dr. Daraj J, and co-sponsored by Walt Yates, and who kind of brought this to the forefront of the military side of taking a commercial application. I'm joined today by Tim Welch, who is my co-host for today and from the NOC TSD team. And together we're going to shepherd this presentation through and trying to get into a little bit more about what this paper was about, their journey as an interdisciplinary team, and how they brought this together from some commercial findings in the medical field around some of the neuroscience and the training and some of the things that they were getting about patient feedback and how that can be used to address some of the modernized needs of training that we see facing our soldiers going forward, and the number of aspects of simulation and training, but also around synthetic training, and all these different sources of content that are coming at the soldiers and sailors and Marines and airmen that we have that are just inundating them with a number of different inputs. And how do they facilitate that? How do they translate that into better learning and cognitive results downstream? And so our hope today is that when we have this presentation, it's going to generate more ideas about how you could potentially use some of these lessons learned and how you could use this study and how dynamically it's going to change the way we view training going forward. So Tim, I'm going to turn it over to you for a few moments to give us some final words, and then we'll kick off into the presentation. And for the folks at home, just before we get started on that, if you have questions, please use the Q&A section of the board to post your questions for the presenters. And at the end of the presentation, we'll go into those Q&A and pull those forward. We also have some pre-submitted questions, which we'll be happy to go through those as well. But you can use the chat function to communicate with the presenters, our staff that are here, but also amongst yourselves. But if you do have a specific question, please put it in the Q&A. So Tim, over to you real quick.
I appreciate it, Kevin, and I'm excited about this presentation mainly because this is exactly what we're trying to bring forward into our ecosystem with the Tech Bridge and the Tech Grove. As a Team Orlando partner, it's great to see some new thoughts coming from a different non-traditional partner and partnered up with some people that we've seen for quite a long time and are happy to see, Dr. Walcott and Colonel Yates. So this is the very kind of exposure and discussion that we want to have, where we've got new ideas coming in, and hopefully we can get a lot of good work out of this and go forward. So without further ado, I'd like to turn it over to the team and go for it. Thank you.
Great. Thanks very much, everyone. My name's Daraj, Dr. J, and I am the founder of this company called QNeuro. It stands for Quantum Neuromonitoring. And I appreciate you guys inviting us. I appreciate all the attendees for being here. And so what we'll do is I'll kind of take you through our journey, kind of where we started, where, what got us to the paper, and then where we're kind of what we've done since the paper, where we're kind of going in that direction. And we have some slides prepared, but feel free at any time to just put in a question if you want to, and then we can always divert from the slides and go into any specific topics, especially if the audience has any specific interests, and it's kind of sparked along the way. So again, company is called QNeuro, and I myself am a neurologist and a medical doctor by training, and I use neurotechnology daily for patient care and really to using real-time neuromonitoring to improve outcomes during surgery. So this is what I was trained in. This is what I do, and this is how I help to improve patient care. So I know what the technology can do. And so the Q Neuro really started off as a question of, well, if we took this same technology and applied it to consumer applications, well, what are the possibilities? What could we potentially do with it? And it turns out there's a whole lot of things. This technology, EEG, has been around for 100+ years. So it's not like we are the pioneers of EEG technology or anything like that. There's some great groups out there, great companies, a tremendous amount of research that's out there that we build off of, and we kind of stand on the shoulders of these scientific giants before us. But we're kind of taking it, we're one of the teams that are taking this to the next level. And so this question is, what can we do if we have a real-time window into the brain? We started off with educational applications, and I'll turn it over to our neuroscientist, Dr. Horton, and he can tell you a little bit about our experience with educational apps and neurotechnology with educational apps.
All right, thanks, Draj. Yeah, so as he said, when we saw this technology, all the possibilities for this, there were very few commercial applications for this, right? This was mostly in the medical field where it was being used, or hobbyist researchers. So on the one hand, there was any number of directions we could go with this. So to some extent, that's a problem, but we really focused in on educational, specifically K through 12 educational content. That was something where we saw there wasn't any use of this whatsoever. Education is one of those fields that's typically slow to uptake new technology. And we saw a lot of potential here for helping people learn better. So I'm going to talk a little bit about what we did, and also a little bit about what the technology actually does. I know that the topic of this presentation is much more about the kind of behind the scenes, but just to give you a baseline. So what we did, we were very much focused on making specific educational content to start. So we were making like a full years of content, like a grade levels content at a time, of math games that were immersive, that were high quality compared to educational games that you typically see. I don't know how much experience any of you have had with it, but a lot of them are basically just digital worksheets that have some little rewards around them. They're not particularly compelling compared to the types of video games the kids are liking to play. But we did focus on really making high quality immersive things. And the key difference is they would connect to these mobile EEG headsets. So this is one of those areas where there had been a lot of advances in the kind of 10 years leading up to when we started in this. Whereas it used to be very clunky to record EEG in a mobile setting, there in the last few years there have been multiple lightweight mobile devices that have better and better signal quality than preceding generations of technology, that were inexpensive, that could connect over wireless or Bluetooth. So you had a range of applications where we could use them. So we could use these to kind of get a picture into the brain in real time, as Draj mentioned. And so from this, what you can do is basically there are some signals that are particularly strong in the EEG whenever your mental state changes. So the things that we were using for educational apps are things like cognitive load. So this is essentially how mentally demanding, really like a working memory load. Things like attention and engagement. And these are things that had been in the neuroscience literature. These had been measured reliably for many years at this point. This was not any like crazy new technology, just nobody was using this in an applied setting, essentially. So we started from a position of, okay, we have these insights. We have these real-time insights into what's going on. So what can we do with this? And there's this wealth of literature that I think Dr. Walcott might discuss a little bit later about people knew a lot about how to manipulate cognitive load to enhance training. Essentially, it's really important to stay in this targeted window where things are as challenging and varied as possible without overwhelming or frustrating people. And there were good parameters for how to do this. And we had this electronic platform. We had these applications, these games that we were making that we could vary anything we wanted. So we did. We built this into our educational content. We had it where the difficulty could be varied in real time, like question to question, not app by section. We had it where the actual audiovisual complexity of the game itself could be more or less complex. So this is something that you can kind of see a little bit in one of the slides there, that we can basically gray out backgrounds, we can simplify the setting, we can get rid of unnecessary UI elements. Some of these rewards elements that might be engaging for people whenever they're playing, if that becomes overwhelming, we can simplify it. And things like we can insert worked examples whenever we're detecting that people are overwhelmed. So there's a lot. This is just a few examples. There's essentially an endless list of all the different things you can control with this. And the idea behind this is, again, we're staying right in this sweet spot where people are being challenged, they're engaged, they're attending to this without ever becoming overwhelming or frustrated. And it's just so much more efficient to stay in that window, right? This is what teachers are doing kind of for their classes as a whole in like a K through 12 education setting. They're trying to kind of maintain this right speed where everyone's mostly following along as well as they can without kind of getting ahead or behind of anybody. And we can do this. We've got this real-time window that we can measure this and do this in real time. So what you'll get out of this then is improved engagement and retention, memory transfer. The idea is you're learning this better, and decreased frustration, which is a really important second metric that I think is not talked about as often. But if you want to look at some measures of when people kind of wash out of or give up on things, it's whenever they hit these frustration levels where they just either think they're not going to be capable of learning it, or if they are, just if they get behind, it's very hard to then catch up, or because you develop these negative feelings towards it. So we had this whole platform that we were building out for educational space, and maybe I'll give it back to Diraj to talk about how that ended up going.
Yeah. So thanks, Court. So what we learned a lot of lessons by putting this out there in kind of real world practical situations. We didn't there's certain challenges with trying to get into school districts and whatnot, but in smaller scales, in classrooms, in our lab, in even the office, in people's homes and things like that, we were able to collect some good data. And what we found is there's some basic things, there's some basic challenges that we had to overcome before this technology could really go mainstream, could really get to the point that we envisioned it to be. One was, we were developing software for other headset manufacturers, and these headset manufacturers have done amazing job in their own right, doing and putting out great products and things like that. But even still, we found some limitations, and the specific things we were trying to measure and target, we needed the electrodes in the appropriate positions for optimal signal acquisition, those types of things. And then there's just these very practical things that people take for granted, but it requires a huge amount of engineering effort. Is it comfortable to wear? Can you wear it for an extended period of time? How reliable are these signals, and how reliable are they over some given extended period of time? What about people's hair types? Different hair types, things like that. So we went about the route of designing our own hardware. Now that might not be the smartest thing to do. And we were advised against it in terms of this being this endless pit that we would be, diving into. But we did it anyways, and we have come up with some what we think are pretty innovative solutions. And we have some contactless EEG sensors that can fit over the hair and still get signals that are they're very close to, if not as good as, the signals for these dry electrode sensors that have to penetrate through the hair to get to the scalp and actually touch the scalp before they get a good signal. So we were able to place these in different areas. We don't have to worry as much about people's different hairstyles, hair types, those types of things. We've came up with some solutions that actually improve the signal quality over, as if a person is perspiring. So we could use it in sports applications, more active applications, those types of things. So we're excited. We're excited about what we've done and about what we can do with this. And it is, a lot of this stuff, a lot of this this thing that just goes into this point of, well, does the technology work, right? So when the iPhone first came out, like, I'm not comparing us to Apple just yet, but hopefully someday, right? But when the iPhone first came out, like, one of the things that I remember going into the store and doing and talking to somebody about was, this just works, and it works like nothing else that's been there before. And that was one of the things that, you have to just be able to put it on, turn it on, and use it. It's got to be user friendly and all of that, but that requires a tremendous amount of engineering from the hardware standpoint, from the software standpoint, and all of that. So I don't want to say we've cracked the code, because we're always a work in progress, but we've made some tremendous strides. And now we're looking at, well, what can we do with this? Where can we get this out there? And there's different applications. There's education, the space that we're still very interested in and we're pursuing. There's workplace performance improvement. There's sports, and then the big one that we came across, and there's some different connections which eventually led this team to come together. But military was another huge application for training and operations. And so for that, I'll turn it over to JJ and Walt to start to give an overview of and a more in-depth discussion of what are the potentials there.
Walt, do you want to go ahead and start?
Sure. Thank you very much. I was first introduced to Diraj back in January of 2020, and quickly realized that Diraj and JJ needed to be introduced and have a conversation about the potential for this technology. And what excited me about it, as coming from a military training and human performance perspective, was that this was a feedback loop that provides a window into the brain that would allow us to calibrate in real time the learning presentation to military trainees and students. And I got to thinking about how that would impact the military training pipeline, how it could impact it. And there's a tremendous opportunity for conserving human potential and not having attrition at both the low end, where we're very familiar with it in the entry-level training pipeline, but also at the high end, where we have a largely unaddressed population of very talented and fast-learning individuals who don't get the challenge that they are expecting and hoping for, and end up dropping out of military service, going elsewhere to look for more of a challenge. And so I thought that this neuromonitoring technology could put people into the sweet spot, into the learning zone, and keep them there. And as Court referred to, when you're in the optimal zone, learning feels good. You don't feel like you're the slow kid in class, or you're bored to death and you're in a place you don't belong. Pseudoscience here from a non-psychologist, non-doctor, but there's probably some dopamine involved in it when somebody's really learning and you feel like I'm doing something worthwhile and enjoying it. So that's enjoyment of military training is something that's very often missing, and it takes a lot of leadership to make things that are somewhat boring and repetitive interesting enough to pay attention. And so this gave me lots of ideas, because in training systems development, neuromonitoring doesn't replace anything that's already in our learning architectures, training system architectures. It provides you a feedback loop that lets you calibrate and adjust. And I think that has huge potential, especially because I believe Diraj, as he greatly described very well, this has to just work. And that's criteria number one for military equipment. If it takes light touch and a lot of skill to make it work, it's just not going to be adopted. And so I think there's a tremendous opportunity for this. We have been in conversation with the project managers for at Marine Corps Systems Command for the helmet, combat helmet, to get approval to start using this as something that augments the helmet lining and can be used to get time-stamped brainwave activity during training evolutions. And I think we're going to make some very interesting discoveries. And in that area. So at that point, I'll pause and turn it over to JJ for her perspective.
Sure. So I think we're going to move forward one slide. I think Walt has covered that well. So jumping into kind of where we've been and where we're going, right? All of the services have started to jump on board with the recognition that we have to personalize training for our military personnel. But the question is how? And so what we hear are the buzzwords, right? We hear interoperability. We hear data-driven learning. We hear personalization, intelligent tutoring, gaming, you name it. However, where is that data coming from? And to date, we are starting to replace observation with other performance metrics that we can capture. But the question that keeps coming up, and the reason I became part of this team, was because asking the question, why are we not using objective measures? Or as Daraj put it, getting a window into the brain. If we have access and ability to do that reliably, validly, and to Walt's point, in the helmet, so it's in real time without even having to worry about additional weight or problems, why aren't we using it? And so there's an answer to that, right? And the answer is 10 years ago, we started looking at this. ONR was heavily investing in augmented cognition and understanding what we could do if we had access to this data. But the problem was, while the technology technically existed, and certainly within the lab, we could get the results we needed, it was not realistically capable for us to outfit folks out in theater or even in training real-time live events. So given that, we had to wait. And so when Walt came to me and said, JJ, you've got to take a look. Let's talk to Daraj, let's talk to Court, let's see if this is where it needs to be. And that's what got me excited and said, we need to write this ITSIC paper. We need to share with the community what's possible. So as you look across in this slide, we showcase each of the services as well as DoD. And for those of you who don't know me, I come from a very varied perspective, right? So I used to work in the lab doing this specific type of research. What do we do with neuro data within military operations, and do that in real time to personalize learning. But I've also worked at the DoD level in policy and working with the Pentagon. So from whether it's at the basic, very precise level of research, or we're looking at the global considerations for training, no matter which way we slice it, we've got to capture this data. We've got to do it in a way that's in real time. And that's how we get to answering all of the particular programs that the services are trying to put into place. And so by real quick, just looking at some of the historical points, yes, the augmented cognition program. So that was back in the early 2000s. That's when we really started to talk about the art of the possible. What does it look like if we're able to connect individuals to all kinds of sensors, grab that sensor data, and then use it and translate our training paradigms in order to be able to affect learning? One of the things that Dr. Horton brought up was that they use this in an educational setting with K-12. One of the major differences between K-12 and military training is the complexity and real life application that we have to consider. It means that rather than looking at improving ability to answer questions or to achieve rote memory, what we have to do for military is be able to translate and apply that information. So now we're into a deeper conceptual space. That requires us to understand a whole lot more about the learning science. And that's where we get into the Verte model, Verte program, and then the SIP model. The SIP model, which we'll show in the next one, I believe that's the next slide, really characterized here. And what are the key points? We always talk about inputs, I, O for outputs, and in the middle, we talk about processing, but it's usually a black box. So we watch performance, we watch behaviors, but what we can do with this kind of technology and in the additional sensors we get from physiological sensors is be able to look at this whole pathway that you see here. Every one of those red arrows is where information is lost due to overload, lack of engagement, threat to learning, or any other thing that's happening in the brain. The part that's in the box where it shows how all the pieces are put together, that's essentially like your brain's puzzle, and being able to combine information to be able to apply it in the real world. EEG can help us understand and keep someone moving through this process at the most efficient way possible. And that's where we start to see conceptually a huge shift. But operationally, what does that really look like? Well, that looks like any activity where we have to have an assembly line, ensuring that we're moving it through at an optimal pace. It means being able to collect whole person data from the mind to the physiology to the behavior in order to personalize both training as well as to, say, dictate when to use augmented cognition and how. It means that when we are looking at stratifying or connecting our teams, we can select much faster and better based on these kind of data. It means from a distributed learning perspective, we can determine what you already know and fill the gaps much more quickly than we ever could before. And so on and so forth.
We lost JJ. Okay, we can have. Oh, let's see, she's coming back. Oh, great. Okay, JJ, you back? Okay, great.
Am I still here?
Yeah, we can hear you now.
Goodness, well, that's always fun.
JJ was always there. You're
Like, yeah, I heard you the whole time.
Yeah. Okay.
Well, there's the punchline, of course, is we have a tremendous number of opportunities in military to apply this technology. And so the question is, what do we want to do next?
Yeah, thanks for that, Walt and JJ. That's great, and that's really, I mean, I can't emphasize enough how excited we are just as a team in general if we could make a difference in military training and eventually in operations itself. I see this technology really being able to impact that, and I do see. Yeah, I see the brain as kind of not the final frontier, but the next great frontier. I mean, I'm obviously biased as a neurologist and a neuroscience person, but that's just it for me. Like this is it. This is uncharted territory that we're just scratching the surface of what can be done, and so that's why this technology is so exciting. And so what we're really potentially looking to do is this we're looking to improve. The nice thing about this is the brain is a central part of any training, any operation, any learning, any system. You're using your brain to do it. The humans involved, you're using your brain. So the information that we're able to get from that is it's here. The technology is here. It's now. It's really what can we do with that technology? So So we've developed, a system with that can be used in multiple different environments. It can be used, we've got some, pretty good algorithms that take out, things like motion artifact, all of the things that have traditionally been pain points for having EEG transfer from the lab or the medical environment into real world usage. We're able to mitigate some of those factors, and we're able to make this more usable in a day-to-day environment. So the question now is kind of posed to you in terms of, this is the audience members, in terms of, well, what is it that you're doing now that you could see, well, if I had this information about, is this person, is their brain working harder during this particular aspect of the training or this particular aspect of their operational procedure? And can we use that information then to make changes, make meaningful changes within that either the training environment, the simulator environment, the operational environment, that will then improve outcomes? That is really the exciting part of this. So, this graph just shows that, performance is on the y-axis, and then your mental effort is on the x-axis. And we really want to move to this point of high efficiency, which is high performance with a low mental effort. And so, and we think that this technology, which gives us a quantitative real-time view into the brain as it's actually doing something, as you're performing a particular task, can do that. It has the potential to do that across a wide variety of different different applications. So our
If I could jump in.
Oh yeah, go ahead.
1 second real quick, just to answer one thing that's come up in the chat. A really key distinction here, as it was mentioned before, is that this is not just another way of measuring the same thing. We're getting this window into the brain really helps us differentiate some things that you wouldn't be able to get otherwise, right? So some people asked questions about like knowing when somebody's mastered things so you can speed people along who are high performance. So one thing you can do, one example I like to give is if somebody gets, say, if you're doing some sort of testing and somebody gets a question right, well, it could be that and say they did it very quickly. It could be that they've already mastered this material and they're ready to move on and they're bored. Or it could be that they don't know what they're doing at all. They just guessed, or that, they've already hit a frustration wall and they just guessed and happened to get the right answer, right? If you're just looking at their outcome metric for that particular question, what you're going to see is just somebody that knows what they're doing and move on from there. But whenever you have this real-time cognitive feedback on somebody, you can differentiate between, oh, this person has this master, we need to get them on to new material before they get bored. Or this person isn't even engaged with this material. They're not doing anything valuable with this time. We're in danger of losing them, right? This is something really unique that you can get to that you're not going to have access to without this additional source of information. So I saw that mentioned in the chat, so I just wanted to jump into that and point that out before we moved on.
I'd also like to jump in and just for the sake of consideration, offer some recent military mishaps as an opportunity where this technology could have identified people who were at the threshold of their cognitive limit and were starting to shed tasks. So think about the collisions with the USS John S. McCain and the Fitzgerald. Also think way back to the 1980s when the USS Vincennes shot down an Iranian passenger airliner by mistake. And if you'd had this type of neuromonitoring, you could have seen things like severe cognitive overload and fatigue, and you would have been able to surge in fresh people and another set of eyes and to spread those tasks out. So these are operational applications where neuromonitoring can help not only in the learning, but in the operational, the execution of missions so that we get the best performance when we need it and we can bring in more human resources when somebody's at their limit.
Yeah, I'll add to that I think it's an interesting concept to think about resource and your humans as a resource, right? And resource management and thinking about how the brain is one of those areas that we don't necessarily measure or keep track of, and ensuring that everyone is operating at their best. One of the things that I often say, and I started one of my talks like this, I said, we lose 22 vets a day to suicide. And that is sobering because it's something we can't see to date. Because if your ankle is broken, we treat it. If your arm isn't working or you've lost an appendage, we know what to do. But when your brain has been overloaded, overstressed, overused for an extended period of time, we don't see it and we don't know what to do with it. But this kind of technology would allow us to start being able to see how much stress is someone enduring, for how long, what is the impact? Are we seeing changes in how fast they become overloaded because now they have residual load that is carrying with them at all times? When they're returning from service, from theater to garrison, do we see changes in the way the brain is operating? All of these points could be tremendously beneficial. I see in the chat there's a question about mild traumatic brain injury, so TBI. And I have to imagine that if we could start collecting data on the brain and how those resources in military are being not only utilized efficiently and effectively, but also safely, that we would see some tremendous impact.
Yeah, no, absolutely.
So I want to.
Oh, sorry. Go ahead.
Oh, this is Tim. I wanted to jump back a little bit to the beginning of Walter's comment about the TBI, and the first question he asked about was the materials that it's made out of. And early on, Dr. J, you mentioned something about that you were advised not to go down a path of creating your own hardware, but you saw that it was worthwhile for some reason. Can you talk a little bit more about that process and some of the things the naysayers got right and got wrong with that, and why that ended up working for you?
Well, I can say we're on the journey. So, if we, right now, so the general, the advice not to go into hardware development was a general advice from, you're going to get it from pretty much, any idea you have, anything that you try to go into, you're going to get people that are going to advise against it, just because, well, it's a lot of work, it's too hard, it's too complex, it's all of those things. I probably everybody on this group and most of the people probably in the audience, we're doers, right? Like we go out there, we take the challenge, and we're like, okay, let's do this, right? And so that's the approach that we took. The reason that we did it was why we developed our own hardware set was because the manufacturers of the existing headsets that we were using, as great as they were, and I've met some of the founders and the CEOs. No company is really big out there. Like this is still technology in its infancy. And so they had everybody has their own different ideas and their own different business models. And what they were looking for wasn't quite exactly in line with what we were trying to do and what we were looking for and where we needed the sensors and all of those things. So really the decision point was, I don't want to say forced, but it was like, if we wanted to continue down the route that we were going and where we saw this technology being able to go, we had to develop an integrated hardware software solution of our own that could really just address some of these issues, some of the problems and things. So that's really the genesis and the point of why we decided to kind of go that route and do both things ourselves, the hardware and the software combined as one total integrated package and solution.
Hey, Dr. J.
And I could add, if you don't have your own, sorry, I was just going to say, if you don't have your own hardware, then you're going to be limited as to types of things you can apply it towards, right? So if we're talking about, if we want to find a particular partner in some military application that wants this incorporated into their existing equipment, if we're using an off-the-shelf system from somebody else that may or may not be compatible with that, we're not going to be able to incorporate it, right? So at the end of the day, to be able to set this into a variety of applied settings, we have to have control over that. We have to be able to modify it and kind of put our own system into these places.
Hey, team, I'm seeing lots of questions, and I have lots of questions too that are popping up. So I want to have the opportunity to get to those. But before we jump into that, because I can clearly see us getting into some weeds really, really fast on this topic because it's really, very interesting. Let's have the opportunity. What's your ask? What is it from this audience that if you walked away from, you'd want as an outcome? And then we'll close with that in terms of your presentation, but then let's get into some questions because I think that's where a lot of people want to spend some time.
Mm-hmm. So I'll start with that, and then I know JJ and Walt would have definitely some things to add, so I'll keep it very brief. Look, we have this tool, and we think it's a great tool, and this tool is really ready to go now. It's ready to go. Yeah, it's ready to go today. If you want to, we could have a conversation. We could see your specific application for it. We could start, and we could figure out how to integrate into there. Each one, each particular instance is going to have its own probably, customization that's involved with that. And we're eager, we're willing to partner up with people with specific use cases where we can say, okay, look, here's an application of this technology, and this is the outcomes that we can have from it. And we really believe that we can improve outcomes at a tremendous output, like at a tremendous level, that we can get to that. Some of the papers that we've seen, some of the literatures that we've seen, a lot of it coming from foreign countries, which is something that we need to also be aware of, which JJ will probably talk to, is that we need to really be on top of this, because if we're not, there's other countries already are, and we will always want to be at the forefront. And this is definitely a technology that will keep us there. And if we don't do it, somebody else is going to. So we should be at the forefront of that. And with that, so what we're looking for is, let's start it at a small level. Let's find use cases for this. Let's start it at a small level. Let's take 10 headsets, 20 headsets, something like that. Let's put it on the field. Let's put it in the training environment. Let's start gathering data. Let's show what we can do. Let's refine those outputs, and then let's really see what we can do with it, see what the potential is, and then we can take it to scale. And that's really what I would that's what I would view as a success, if we could get that from this talk, or eventually what we're trying to do here.
I'd like to add from my perspective as a former government program manager. It was always amazing to me that it was easier to find money, especially in small amounts, for a pilot project or a study, than it was to find a well-written requirement. So my ask to the government would be have the courage to go ahead and put neuromonitoring into the requirement description for your training architectures, because too often that type of requirement is omitted because people think it doesn't exist and there's no reason to put it in there. This actually exists. It's at a TRL 6 or ready for testing to be certified at TRL 7 or higher. So put it into the learning architecture requirements, and it can be delivered. And the two basic ingredients to any contract or OTA are a requirement and the right time, purpose, and amount of money. And the requirement is harder to get in most cases.
Yeah, so I'll tie a bow around this, saying, echoing what Walt is saying. Number one, to our program managers and our govies, please put some requirements in. To our industry folks, if you are doing anything in AR, VR, XR, gaming technology, intelligent tutoring, any kind of personalized education, having the data that you can get from objective measurement matters. And this is a plug and chug at this point. And I'll add to that, because I can answer two of these questions from Helen and Jeff simultaneously. Yes, there is tons of research. I can supply any of it to anyone. It is not the case that all of that research is tied to this particular EEG headset, but we have, through Office of Naval Research and through DARPA and other areas, conducted a fair amount of research in complex decision making, and demonstrated that being able to objectively measure adds to our ability to improve decision making long term, and that is beyond what we can infer from performance alone. So it's those requirements. And then I would say, last, to those writing the SIBRs, this is the kind of place where a SIBR makes tremendous sense. It's low risk because we already have the technology tested, and because we've already invested so much money in it. The goal is actually to be able to bridge the research practice gap, to just take this across the finish line, and to loop it to Diraj's point. Let's get 10, 20 headsets in place. Let's tie it to existing technology, demonstrate what it can do, and then fly from there.
Awesome. Thank you for bringing that together, because and ending on that note too is the fact that I want to kind of hit on a couple of things that kind of popped up in my head. One, you mentioned this is a tool set, and then also I want to ask about the ecosystem that you're trying to build. And when you say a tool set, to many people that implies that there are APIs or there are other things that be dropped into an existing training application. So I'd like you to expand on that. And then JJ, you also mentioned XR. My first impression was that this was CBT based, but it sounds like this could be used for any type of XR application as well. So I'm hoping maybe you could expand on those 2 points.
So in talking about the interoperability, so we have a variety of skilled programmers on our team. That and we've had to make things compatible with, in the gaming environment. When we were doing educational games, we've tried to make it compatible, so it's compatible across pretty much all operating systems. It's iOS, Mac, PC, any of those systems. But we can also target very specific applications and programming languages and things like that, so that there is interoperability, that there is going to be an SDK. There'll be an API for a plugin that can be used for existing training simulators, training apps, those types of things. We just have to have those conversations with the designers of those programs, or that we can then just create our plugin that will just seamlessly integrate into the system.
Awesome.
And I should point out, a lot of the complicated stuff is all happening behind the scenes that the user doesn't have to deal with, right? So it's building this hardware is building individualized models for each user. It's using machine learning to update itself all in the back end. But the output doesn't have to be that complicated to the user. We can output as simple as just the metrics of what things they want to know. How demanding is this? How engaged they are? It can be very simple outputs, even if a lot of complicated stuff is happening in the back end. So people don't have to have a neuroscientist on staff to be able to make use of this information.
And Daraj, I'll cue you to the point of the physiological elements that you can capture as well. So when I think of a tool set from my perspective, from the learning science perspective, I not only want to know what's happening in the brain from a workload and engagement perspective, but I would also like to know what's happening from a stress perspective. And I know that has been recently incorporated as well.
Yeah, absolutely. And so we do have we have other biometric data that's coming into our latest headset. So that's being actually integrated into the firmware as we speak. And so we've got heart rate, respiratory rate, blood oxygenation levels. We've got these other biometric factors that you can say, okay, look, we've got our EEG data, which is coming in here. That's showing us, oh, there's a spike in your gamma activity over these particular electrodes at this time. Well, how does that now correspond with has your heart rate increased? Is it decreased? And we can start getting profiles, and we can start using that information to say, oh, this person has run through this training. And look, as they got the training, they improved their results of their outputs and the outcomes. Well, look, we had these changes in the signals. And now we can say, okay, look, we can run an expert through this and say, this is what their signals are. This is the novice. And we can even start, engineering the system to track and try and get people to that particular point, using some of this biometric data as a target point. So there's a whole lot of different avenues that you can get to. I'll just briefly mention this one archery study that was done where they found that they got certain profiles. Here's your EEG profile. Here's your heart rate. Here's your respiratory rate. And this was an expert archer that was doing it. Then they got the novices that had no prior experience, and they got these people to kind of get their brain state to a particular, to match the EEG state of the expert. They got their heart rate down to a particular level. They got the respiratory rate so that it matched the expert level. And then they did their training sequence, right? And they found that these people achieved their, a high, accuracy level in their archery much, much faster than the novices that just tried to figure it out on their own. And so there's just so many different ways that we can use this data, and that it's just it's exciting,
And then
and as we get into more,
yeah, go ahead.
Good. I was just going to say, as we get into more and more inputs to this eventually becomes a more traditional, big data problem, right? We have all of these starting points. So, there could be various other performance metrics for soldiers or users coming into it. We have all of the data that we collect whenever they are doing tasks, and we have all these outcome measures. Once you have enough of this data and you've scaled this, now you start getting some really powerful predictors, right? Now, maybe what can we see before they've even done any training that might be predictive of where they're going to end up, or maybe better strategies for how we can approach the training, or who, maybe we can differentiate even within, say, some group that's going to receive some training. Maybe just from the start, we can start grouping people into groups that are going to move through quicker or use a different type of training or instruction. So there's a whole lot of things that you can do with this once you scale it.
Yeah, and then I'll address the ecosystem question. Obviously, this is something that's near and dear to my heart, and we've been working on tremendously at the DoD level. And, this is where we get into what we call the enterprise digital learning modernization, and also the data modernization plans. And so if I were to layer that, right, first you've got to have the interoperability in order to be able to share data, but you've got to have the sensors to be able to capture that data. And those might be environmental sensors, those might be apparatus sensors, or they might be, in this case, human sensors, but we need as much data as we can get. Then we get into, and I assume we probably have some folks on the call who are in that next layer, which is the analysis layer, right? So now we're into the machine learning, AI, big data analytics. Then all of that rolls up into our third layer, which is the layer in which I work. And that's looking at, okay, great. Now that I have the data and I've analyzed it, what in the world do I do with it? And this is where Walt and I really come together and say, okay, JJ, what can we do from a brain perspective to make the brain work faster under certain circumstances? And then, Walt, where do we apply that? And this is a place where we spend a lot of energy. And I can tell you, and I see in the chat, there's a number of questions. Can we connect this to fatigue prediction? Can we predict decision-making capabilities? In fact, we've been able to demonstrate with the combination of EEG and performance data when somebody is about to make a poor decision. Imagine what you could do if you can just demonstrate, wait a minute, you're about to make a mistake. Let's pull you back. In a training scenario and simulation, I can actually pull you out of the training scenario, reteach you what you need to know correctly, and put you back in. Why does that matter? Because I don't want you to learn it wrong the first time. Anybody who's driven to the wrong place the first time, on autopilot, keeps driving to the same wrong location. It's because the brain learns that pathway. We don't have time to be retraining people. And that's like scratching the surface, right? There's so much that we can do. When we can predict your decisions, when we can monitor your stress, when we can take you in and out of chaotic environments, when we can utilize the affordances of other humans and other apparatus in an environment, and it explodes from there.
Yeah, certainly. I think you could address the whole thing about training scarring in advance. So you're preventing the injury, the bad learning, the bad habits before it actually occurs. So I think that's really intriguing. Tim?
So I hate to raise the big bad boogeyman of cyber, but that sounds like a tremendous amount of data about an individual that might be a little risky. Have you started exploring what it means to lock that up a little bit and make it a little secure, make it usable for a DoD network?
I'll take a stab at that first, and it comes down to basic cyber hygiene to begin with. Make sure that your subjects are anonymized and that your data is encrypted both on the wire and where it's stored. But we deal with PII, and this is performance PII all the time. So in the Marine Corps, we have the Marine Corps Training Information Management System, which has your performance scores on physical fitness tests, marksmanship, martial arts, and a cognitive performance profile could fit neatly in a different data storage format, but could fit neatly within that same database context. So we already have best practices established. You just need to observe get the right advisors to build your architecture for that, I think.
And I think that leads also to, you brought up the big data and how much of this data you actually have to capture and control in various sample rates, right? How much data do you really, it's like the whole digital twinning. You can digital twin an entire cross the Atlantic flight of a Boeing 737, but that's so much data. I mean, you'd be stuffing the big data warehouses with so much data that I think speaks to JJ's thought is, then how do we analyze it? And then what do we do with it? So how much of this data do you really need to capture, and how frequently do you need to capture it to get meaningful impact on those students' performance?
I can comment a little bit on this. So you're right. Like if you're taking this down to individual, like millisecond by millisecond samples of EEG, this becomes an overwhelming amount of data. But the reality is, what we're interested in is not exactly what spikes are happening in your brain. We're interested in cognition. We're interested on the window that's going into cognition, and that is something that's developing over a slower time scale. Still relatively quick, but this is not, we don't have to have millisecond by millisecond data on that. So what you need to do is basically set up from the beginning, what are the things that you're actually interested in measuring? How can you get reliable metrics of that, and have all of the complicated stuff be built into the model that's happening on the hardware side, so that the outputs that you're saving from that are the things that are useful to you, right? So again, that could be expansive. There could be 20 different cognitive metrics in the end, or physiological things that we want to measure. So this could get to be a relatively big list, but that's still, 20 data points per second, or however long or however quickly you want to do this. It's still a pretty trivial amount of data compared to things that are collected for other stuff. So I think it's just important to be very thoughtful about what you're actually after, and what we want to know is these cognitive measurements. This is really the key for us. It's not about all of the fine detail of the EEG itself.
Very good. Another question that I had was around the integration. Well, actually, this was one of the questions, and I think, JJ, you kind of addressed a little bit, is that out of the lab and into practical training, but then into field work. Have you been able to translate the findings from each of those three stages to some meaningful data points that the audience can take back and say, well, I see that, I can apply that to my program? Uh-oh, that was a tough question. That was open to anybody.
Well, I think the challenge here is that getting access to military funding to be able to get into operations is a hindrance. And so that is why you see Walt and I saying requirements, 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 requirements. You've got to write the requirements. And in sweep up funds, you've got to have somebody saying, hey, we're in a position where this is something we want to see happen. There is every reason to believe this would be incredibly low risk. I like that Walt called out TRL level 6 or 7. I mean, this is not a leap. And so why we aren't testing it is the right question. One of the things that we've submitted to ITSIC this year is a review of the folks that are working in this area, and Daraj called it out. It's our adversaries. So if we're not going to optimize, I mean, I'll just be blunt. If we're not going to optimize the human in the loop, we are operating at a significant disadvantage.
Yeah, that's a great point, because unfortunately, shiny things draw money, whereas investing in human skills don't. There's a subconscious bias against training, because at the end of the day, we're just going to discharge that person. They're going to leave the force, and we're going to lose the benefit of their expertise. That's not necessarily true. We can capture that, but it's also absolutely necessary that you train that person who's in the force today, because it's always a true statement to say you go to war with the force you have, not the one that you want. So you make it as good as possible and as capable as possible right now. Another idea is that when there is a lack of requirements, a tactic that I have found is working surprisingly well is try and go around, no offense intended here, I used to be a part of it, what I call the thick middle of the DoD, and go to the users. If you can get access with, of course, IRB approval to do limited testing and demonstrations, the users generate a demand signal that the supporting establishment cannot ignore. Whereas from the outside, you can jump up and down all you want, and the requirement may not come. But the supporting establishment, the headquarters, listens to the users. And so getting them excited about it is important.
Very cool. Tim, do you want to, so we're near the top of the hour. So I want to give the panelists an opportunity to any just like final closing points that you'd like to make based on some of the questions that you've heard and the dialogue that we've had. And then I'll give Tim an opportunity to close down as well.
Sounds good.
We'd just like to, thank everybody for attending. It's as you can see, and we've gotten some great questions, great thoughts here. It seems like there is enthusiasm for this, and we would just love to be on board and team up with different partners and see where this technology can really go. I'll leave it to the other panelists too to give their final thoughts.
Yeah, I'll follow on one more thing that I was saying about the importance of focusing on the human and the competition between skill and shiny things. The barriers to entry for our adversaries to training people are very low using this technology. So if we don't, they will, and that will be their offset against our technological advantage. Better trained people and more awareness of cognitive load on their force. So that's a scary prospect.
Tim or JJ?
Oh, I was just going to add. So I'll give as my parting thought the point that Walt made about losing those folks at the top. One of the things that we had in our office at the Pentagon was from General Madison. It said, "Do we have a training problem or a selection problem?" And this was pertaining particularly to identifying and training our cyber warriors, and the problem that we were having such a massive amount of attrition and loss of capability, both at the highest end, and we could not train at the lowest end. So I look at that, and I look at that as the parent of a currently budding Army cyber defender, and hearing her woes. We absolutely have an eligibility problem and difficulty retaining some of those highest end intellectual folks that we are going to need in the next fight. So I think using technology like this to identify and maintain that high level of challenge may prove to be more than just interesting, but definitively necessary.
Well, I greatly appreciate everybody that joined us today, and I think to foot stomp a little bit on some of the conversation at the very end. I see a lot of names that I recognize, both government and contractor, in the audience, and I would love for you to take this conversation back to those that you're working with. One of the big goals of this is to elevate these conversations, get them out of the dark corners of ITSIC or other areas that we just don't ever have a chance to publicize them, get them foot stomped with our sponsors. And I really appreciate everybody that asked questions, and please reach out to this team and talk more. Keep the conversation going beyond just this hour-long chat.
Thanks, Tim. And what's the best way to get a hold of this team? What's the conduit? Who's the point of contact, and who should we direct some of these audience members towards?
Well, I just put my email address in the chat, so if anybody wants to contact me, feel free.
Awesome. Great. So with that, again,
I'll put my email as well.
Thank you, sir. So with that, thank you again, everybody, for joining us for this month's Connect call. We look forward to bringing more stories and more of these insightful discussions, coming forward in the next couple of months. And this is, again, I say this every time. Every time we have one of these conversations, I think it's better than the last one that we had. And it just keeps getting better. So kudos to you guys. I mean, you got some great technology. It's really exciting to see what we can do, and the measurement of the brain waves, and going forward, how we train our military trainees coming forward. And I think it's really fantastic. So we'll keep abreast of what's going on in the industry. Look forward to seeing you guys at ITSIC this year. And, as we meet back in person. And, of course, as you guys develop any type of follow-on, if there's some additional messaging that you want to give to us so that we can pass through the tech growth, we'd be happy to do that, to keep people in the loop and let them know how you guys are doing and progressing with this program. So we appreciate your time and, all the work that you've been doing. And again, we look forward to helping you, drive this program forward with some of the people that are on the call and connecting all those folks. So again, thank you very much, everybody, and we'll see you next month.
Thanks.